Hi there, I'm Paul Collins. I'm a Senior Program Manager with the Microsoft 365 team. I'm really pleased to be here presenting to you today on our Microsoft 365 network connectivity video series, and specifically we're going to be talking around enterprise network design for the cloud era. So this first slide, you've probably seen in the first of the video series, but we'll just go over it again for context of how it applies to this session. As you can see on the screen, there is the 4 Microsoft 365 network connectivity principles. These are the principles we need to follow to get the best performance out of the Office 365 Microsoft 365 service. So in a nutshell, they are optimize Microsoft 365 traffic. So we use the REST API service that we have. We mark the endpoints in certain ways that you can differentiate how you treat them, because there are many of them and they all have different properties. We can mark them in certain ways that you can send some direct and others can be treated like normal web browsing traffic. Second principle being enabling local egress, getting that traffic out away from the user as close as possible as you can with as minimal of latency. That's so it can hit Microsoft's infrastructure, which is normally very close to where that user may be. Third, relatively similar to the second, but enabling direct connectivity. And this means avoiding hairpins. So avoiding sending traffic through a head office location to come out to the internet, avoiding VPN hairpins where we go in and out of a corporate network to get to the destination, or sending it through third-party cloud services to come back out to Microsoft. And we'll look into what that means during this session. And finally, modernizing security. Obviously, this network transformation means routing traffic away from our security stack that we've designed to protect our corporation or enterprise. The modernized security for SaaS principle is about how do we deliver and technically improve on that security while still avoiding that infrastructure that we've built for the on-premises world. Let's dive in. So this first slide, if you've seen me present over the last few years, you'll find it familiar. And I like to use it to set the scene here. What is the challenge? Why do we need to change what we're doing that's worked very well for many years? Well, this slide helps articulate what an enterprise network looks like before that cloud journey, in that the network, the security infrastructure is designed around the on-premises world. So that dotted line you see on the screen is our CorpNet, and inside that dotted line is where we keep our crown jewels, essentially the business. Our data, our services, our applications all sit within there. So generally from an enterprise network perspective, if we're on that network, we're trusted. If we're outside that network, we're untrusted. So to get to anything outside of that, which is generally web browsing, we have to go through a security stack. So that means proxy servers, DLP, firewalls, CASBs, intrusion prevention, and so on. These are expensive equipment that are designed to protect that CorpNet from unknown and untrusted endpoints outside. And that's perfectly normal because everything that lives within that CorpNet is, as I say, what we trust as a business. Everything outside is untrusted. So that means all our network infrastructure is built around that. This stack is expensive to implement. So we tend to see these in head office locations, maybe 1 or 2 in each regional location of the world, one in APAC, 1 in North America, 1 in Europe, and so on. And then we build the network around that using something like an MPLS network to connect our branch offices back to our head office location to egress out to anything we need to go, so web browsing, or to access those resources that we tend to host at our head office location. And also our roaming users are built to deal with that in the same way as a branch office, in that we use a VPN in this instance to route all that traffic, web browsing, whether we're accessing mail, file servers, whatever, we come in via the VPN and then we can access all those resources. And if we want to go out to the internet, we hairpin through that corporate network back out. And that has served enterprises very well for many years because it's there and it protects that CorpNet, as I say, from anything unknown, untrusted that might be trying to attack it from outside. Now, the problem comes when we start to move to the cloud, and Microsoft 365 is often one of the first things that pushes this door. So we start to move those crown jewels out of that CorpNet. Our data, our services, our applications start to move out into the cloud. And the problem is if we treat the traffic connecting to those endpoints in the same way as we treat a user browsing a YouTube or any website, then we start to run into trouble pretty quickly, because that work, that security stack, that backhaul to that location with egress, it's expensive in terms of latency and the physical cost of paying for that infrastructure to deal with that. The impact on Microsoft 365 generally is poor performance. We're increasing latency as we do all these functions, as we VPN in, as we backhaul from the branch office, as we go through the proxy, through the DLP device. The end result from a Microsoft 365 perspective is that we get poor quality calls, sluggish behavior in Outlook, slow uploads, downloads into OneDrive as examples. I mean, we're going to focus here today on Microsoft 365, but this problem exists for things like Azure. If we're connecting to Azure through this stack, the same problems apply. And then there are other things to think about. There's been a shift in the way that we deal with Windows and Office updates, that previously we'd roll out a service pack once every year, couple of years, and it'd be a slow, measured approach. But in the cloud-first world, everything's evergreen. We provide updates on a regular basis to mean that the service is always evolving and improving. So that means that fairly large update packages can be pushed out on a regular basis. And what we've seen with some customers is the MPLS circuit there, for example, or the VPN concentrator in the times of COVID, where everyone's coming in through that at the same time. That can be an enormous volume of traffic that we're having to deal with all of a sudden, that can take away those resources that are also used and required for business critical services. And it's important to note here, again, we're going to be focusing on Microsoft 365 today, but this problem exists for cloud services in general. Most cloud services will want to follow very similar principles to what we're going to discuss here. And the network design we're going to look at is designed for that in mind. There's a great anecdote I can provide here. A customer I've been dealing with over the past a couple of years, really, on and off, has moved from pretty much the model you see here to nearly complete cloud usage. So they said that 80% of their traffic 3 years ago was internal to that CorpNet and 20% external. And in 3 years, that number has flipped. So this network model does not lend itself well to that world where 80% of the volume of their traffic is going to some external cloud-based resource or the internet. And they have gone through some of the changes, the improvements that you'll see here today. And you'll see it's a much better fit for that cloud-first world. This network infrastructure served us very well for a long time, but it does need to change as we move into the cloud era. So let's look at that traditional network approach just to give a baseline for what we're going to move from. So in this example here, on the left, you can see a Sydney branch office there, where we've got users that send all the traffic through from that location through the MPLS back to the head office location in Singapore. Then to get out to the internet, we go through a proxy. We have those DLP devices we discussed on the previous slide. And then that means from an Office 365 perspective, that user that's accessing Teams, SharePoint, Outlook from Sydney, from Australia, is routing that traffic through Singapore, and it's hitting Microsoft's infrastructure in Singapore. The common results we see with this is that we see high latency. And I mentioned earlier, latency is our key currency here. We want this as low as possible to hit what we call the Microsoft 365 front door. When I use that phrase front door, what I mean is Microsoft has infrastructure around the globe. We have a global network that has locations at internet peering locations, pretty much most metropolitan areas that have internet exchanges. Microsoft's network is there. And we also have what we call a front door. So this is where the client will connect to consume the service. So a user's data here in Sydney might be hosted in our Singapore or APAC data center region, but that user in Sydney, with the right approach, can use the service front doors for Exchange, for Teams, for SharePoint and OneDrive locally in Australia. So you can see there the latency to do this connectivity from Sydney is around 140 milliseconds. So that's pretty high. I mean, Teams, for example, they have a round trip time aim of being under 100 milliseconds round trip time to the relay server, the front door for Teams. Now, instantly in this scenario, we're over that. Teams will work, of course, but we're pushing that latency envelope, so we may see call quality issues and meeting quality issues. The other problems are things like high load on that centralized egress, that all this exchange traffic, this Teams traffic, imagine we're having an all hands call, so all that Teams traffic and everyone's on their email and SharePoint at the same time. That's an enormous load going through that infrastructure, that internet proxy that didn't go through there before. So that can then have a knock-on impact on things like web browsing, other business critical use that uses that egress, which is obviously not something we want to do. The other problem, if we think about the MPLS, the circuit between Sydney and Singapore, that's obviously used for other business critical traffic. We're again putting high load through that MPLS as we use all these services. Again, on all hands Teams call, for example, all those users pulling that traffic back and forth over that WAN can then impact other things. And if you think back to the previous slide, I was talking about updates. That MPLS can be overwhelmed with the number of packages of updates that are being pulled in, for example. And this is an expensive model to deliver in many locations around the globe. MPLS circuits can be extremely expensive in some areas, much more expensive in many cases than local internet. The other thing is, I always like to think about this in terms of the ability to adapt to changing needs and requirements. We could throw money at the proxy or the MPLS here to boost its capacity to deal with this problem. But then what happens when the next cloud service comes along that needs to use this model? Do we throw more money at it? And we're not really solving the problem. We've still got that latency there that we can't throw money at and remove using this particular model. And from an office perspective, as I say, the end result will be poor quality Teams calls, meetings, sluggish Outlook behavior, slow file transfer into OneDrive. None of these, obviously, anyone at Microsoft wants our customers to have, and I'm sure anyone deploying Office 365 wouldn't want their users to have. So this model is inherently not well designed for SaaS services, for cloud services in general. So what do we do to fix it? Well, the most popular way we're seeing customers evolve to deal with this problem is changing the router that used to connect that MPLS between the two locations from a router to an SDWAN device. And you'll see there we've got some additional connections into that SDWAN in Australia now. We've got two commodity ISP lines that connect us to the internet locally in Sydney in this example. We've still got the MPLS circuit there that's plugged into the SD-WAN that connects us. But what this now allows us to do is use the connectivity principles from an Office perspective. We highlight those endpoints that are critical, the optimized marked endpoints as we call them. So these are the high volume, the latency sensitive, the high connection count, all these things that are going to put pressure on the MPLS, on the proxy, on the centralized egress. These are marked as optimized, and there are literally at the time of recording only 4 FQDNs and 20 IP subnets that correspond to those, and they don't change very often at all. So what we can do with this SD-WAN device is say, okay, let's read Microsoft's REST API service and pull that information in. And if we see connectivity going from a client to those optimized endpoints, we send them out of one of our 2 ISPs that are connected in here. And what that means is that that user connecting to Teams, to OneDrive, to Exchange, they can connect via that ISP to the service front door that Microsoft operates in Australia. So this might be at our network edge or in the data centers themselves. So what that means is we can then deliver much higher performance levels for that user. And we've removed that problem of high volume on the MPLS, the WAN, and also on the centralized egress. And that MPLS circuit is still there for any traffic we still want to send by that path. So the bulk of the Office 365 endpoints can be sent by here with no problem. We've solved the problem by optimizing that small subset of endpoints. So once we've implemented this model, the common results would be, and you can see here, the latency to the service front door from Sydney in this scenario would be around 10 milliseconds. So that's an enormous improvement in latency to the service front door. And this will then reflect on the service quality. You'll have high quality Teams calls and meetings, high quality responsive Outlook functions, high speed transfers into OneDrive for Business, and it's removed all that load from the central egress and the MPLS circuit. And what we're seeing many customers do as they implement this model, you can see there on the slide now, the MPLS circuit is gone. we see many customers reduce the size of that MPLS circuit, saving cost, as we're starting to push out big bulk of our traffic. And I think back to that customer that's 80% cloud-based now. There's no need really for an MPLS anymore because all those services are based out on the internet, and we found a secure way to connect to those directly without having to use our internal infrastructure that was built for the on-premises world. And you can see on this screen here, this is extensible to anything else we deem necessary. So we can use the local breakout for things like Windows and Office updates. Any other cloud service we connect to where we have trusted known endpoints, we can configure the SD-WAN device to just send those direct. And again, you can see here with the green lines, we can use these SD-WAN devices to just build fault-tolerant tunnels over the internet path back to head office for that 20% of traffic that still needs to go there. It's a very interesting and very powerful model that we're seeing customers very successfully implement. And many are reporting to Microsoft that they're seeing significant cost savings on their network OPEX by implementing this, many up to about 60% year-on-year spend on the network. And the added bonus of giving great performance, great usability for cloud services. Just expanding on that model a little further, if we think about that previous model, we were still sending our web browsing traffic back to head office to go through those proxies. Now, in the cloud first world, there's a much more efficient way of doing that, and many customers are heading down this path where instead of hosting their own internet browsing proxies on the premises in the head office data centers, they're switching to things like cloud-based secure web gateways. So fancy word for security as a service, essentially, proxies, security services in the cloud. So you can see in this example, we've got two branch offices again, one in Sydney, the one we were looking at before, and one in Auckland and New Zealand. So we can use this cloud-based secure web gateway, and this company that provides that might have nodes in Sydney, in Singapore, in Tokyo, in London, and so on. So we find the nearest one, we fire all our internet browsing traffic at this cloud-based secure web gateway, and it connects to the internet from there. So we're utilizing that lower cost bandwidth to locally break out. And this is where we're moving towards that kind of internet first model, where the corporate network it does retract in size to the point where it becomes not there anymore, which is the end goal a lot of customers are aiming for. But this enables customers to provide secure web browsing for their clients, their branches, utilizing that lower cost, high-speed bandwidth they've got at the branch office and still maintaining control of that browsing. So we can access things like Windows Update through here. But one of the points we wanted to make here, those optimized endpoints I mentioned before, we would still recommend very strongly that they are sent direct. And if you look at this example, this is an example why that might be. So in this instance, we're talking to the nearest cloud proxy, which is in Sydney. So for the Sydney branch office, this is fine. It'll be low latency to hit that node. But from Auckland, there isn't one in New Zealand. So the nearest one is in Sydney. So we've got additional latency again. And this is the problem of that principle number 3, avoiding hairpins. I would consider a hairpin where we're sending traffic away from where it needs to go before it hits Microsoft. Because you can see on the slide here, we've got a New Zealand service front door. So we have infrastructure in New Zealand, which will expand considerably as our new data center there opens. So what we would always recommend, even with these cloud-based secure web gateways, is we utilize that SD-WAN to intelligently read Microsoft's REST API service and say, if I see those optimized endpoints, I'm just going to send them direct. And I can then hit the service front door, Microsoft's network, our infrastructure, instantly within a few milliseconds in these cases here. And we've still, again, got those links back to our head office should we need them for anything that remains there. So this is a very popular model I'm seeing customers use more and more, and it helps them really sweat that asset, that SD-WAN, the local high-speed bandwidth that they put in. And it improves things like web browsing speed. And if you think also in terms of what this looks like from a security perspective, I'll talk about how we deal with that problem in the next slide. You can essentially think of a branch office as a user, a VPN user, a remote user. In this time, the time of COVID, where everyone's working at home, if we put these principles in place, a user becomes exactly the same as the branch office. And if you imagine in this scenario, if we've got this model in place, we can tell that user, any web browsing, just find your nearest cloud web gateway. We configure the machine, the PC to do that. And our optimized endpoints, we use VPN forced tunnel exception, split tunneling to send that traffic direct. So we're removing the bottlenecking of all that traffic that's coming through my VPN concentrator by applying these principles. And that's the great thing. When we implement these changes, think back to the statement I made before about allowing businesses to be agile. The customers I've seen that have gone down this path and implemented it to a large degree have really had to do very little to deal with 100% home working, because there is no bottleneck on premises. There's no VPN concentrator that has to deal with all those users connecting, because most of their traffic is sent direct to the service. One of the other advantages of this model is these SD-WAN devices can provide other services like local DNS. Many cloud services, including Office 365, rely on local DNS to find the local front door, the nearest node for you to connect to. And this SD-WAN approach, another benefit is that SD-WAN can deal with that problem for you, that it does local DNS for you. So we're not having to rely on that DNS in Singapore, which means that we may get infrastructure or front doors that in Singapore because we found them via DNS. To move on from this, the obvious question is, okay, we're going to bypass our security infrastructure that we know and love and trust. What about security? You know, what's the risk to my business of doing this? I've built this infrastructure that inspects my traffic as it goes through and it protects my business. The way I like to look at it is that in this example, we're not talking about sending every piece of traffic to Office 365 Direct, just those significant optimized endpoints. And if we take Exchange as an example, on the on-premises world, most corporations will have Outlook connect to Exchange without being inspected, without being sent through a proxy. You know, so we have a direct connection between the two. In the cloud world, all you've done is really lifted that Exchange server and put it into Microsoft's cloud. So we don't need to be treating that traffic the same way as we do a user browsing, as I mentioned before. So from a security perspective, what we do is we deal with the security as the data comes in and out of the service, not as the client connects to the service. That's the difference. So how do we do that? Well, from a Microsoft perspective, we have various features that are already built into the service that can be turned on or are there automatically that often replicate all the things we're trying to do at the network edge in that security stack. In terms of AV scanning, DLP can be applied against those endpoints. We've got Exchange Online Protection, we've got Office ATP, and all these things are often replicating and probably do a better job because they understand the service and the protocol better of securing that user. But one of the key components of this model is zero trust. And I've touched on it throughout this presentation. It's really about moving away from trusting the fact that a user is on a trusted network, i.e. our CorpNet, and they have the credentials. Therefore, you're good to go. You can access anything you need. That model is inherently insecure. And that's the benefit of moving to this cloud model, is that we can apply this zero trust in phases, and it allows us to have much more granular real-time security decisions that allow access, rather than just relying on the fact that a user's in a trusted place and has a credential. So there's another session that we'll deliver as part of this that will cover this in much more detail. But I just wanted to touch on some of the elements here that might be of interest in terms of we use identity with strong authentication across the estate. We use visibility of the devices using things like Intune, where we can see the compliance, the health status, that it's domain joined before we grant access to our resources. Applications, again, looking at things like shadow IT, we move that security to the data, that we move from perimeter-based data protection, because your data doesn't live within that perimeter anymore. That's the key thing here, that we move to data-driven protection, that we classify data, we ensure it's encrypted, and we restrict access based on policy. We look at infrastructure here, where we can automatically flag and block risky behavior and we employ least privileged access principles, for example. So we could, remove a user's privileges, rights, access if they move roles, for example. We don't assume that that access goes with them to their new role. We reapply it. And then I mentioned network. We don't trust the network anymore. That network is going to reduce in its capacity to host things anymore, and there's no reason why we should just trust that network in the first place. And one of the key elements of this is Azure AD conditional access, as it says on the screen then, maintaining control in a cloud-first, mobile-first world, where we can use elements of our behavior, our access, to change. So again, we're not trusting this user because they've got credentials. We let them at the data. We can look at things, as I said before, like domain joined devices. Is this a device I've not seen this user connect to this service before? If so, we ratchet up or we block access. We trigger MFA maybe if we've not seen a user log in from here before. Is the IP range something that we need to consider here? Is the user connecting from a region of the world we don't want access from? All these things can be analysed in real time. We look at that risk and we apply appropriate policy rather than just trusting the fact that this user has the credentials and they have access. As I say, we'll dig into this more in one of the later modules. And one of the key questions that always comes up around zero trust and the modern network approach is, okay, I've implemented the feature called tenant restrictions, which means that I block access to any tenants other than those which I implicitly trust. So how does that work if you allow users to connect directly? Because that feature is applied on proxies. Well, the answer is, if you look at the model on the screen there, we've still got those local breakout links via the SD-WAN from the branch office. But there is a separation between the authentication and the connection to the service. So we optimize those marked endpoints, the connections to Exchange, the TCP connection to Exchange, the UDP connection to Teams, and so on. But the authentication is done through the proxy still. We don't need to optimize that. That's a relatively irregular function. We ask for a token as we access a service, and we can cache that for a period of time. So that authentication can still continue to come through the MPLS, through the VPN, whatever model we have to come into the corporate network, and we then apply that feature as normal. Then if the user is trying to access a tenant that is not trusted, we refuse to issue the token. So even if I can make a TCP connection to Exchange, I do not have a token to access it. So that TCP session is useless for me. These features can still richly apply and deliver the security and control that we need, and it doesn't break that by implementing this model. Hopefully that session was useful for you to see an insight into how Microsoft's customers are evolving their network infrastructure and their connectivity to be much more agile, providing higher performance, optimizing user connectivity to the service, and also giving themselves much more agility to deal with problems that come at them, like the sudden shift to remote working this COVID-19 crisis has driven on all of us. For more additional resources, we have our Microsoft 365 Network Connectivity video series page, where we'll cover in more detail some of the elements I've touched on here around the principles, zero trust, and we'll also got some interesting tooling that will help you highlight where your network connectivity is aligning to these principles or where it may not be, and some remediation actions you can take from there. And with that, I'll wrap up. I hope this session was useful for you, and I hope the rest of the sessions are useful also. Thank you.